Today we're going to learn about even and odd graphs. When we look at even and odd graphs, we're looking at what makes a graph even, odd, or neither. We're going to look at it in two ways: graphically, by looking at the graph to determine it, and algebraically, we'll do some algebra to determine it. This is not determining if the equation is even or odd. That is determined by the degree of the equation. This is concentrating how the output y is achieved. So we're going to take a look at these three graphs when we're examining this graphically. Start with the first one. So with the first one, if I have some point right here, we would say that that is x, comma, f of x. We're really used to x, y, but if we're thinking about an output, we can call that f of x. If I then take that point and I reflect it over the y-axis, I would then get the point negative x, but f of x is still positive. And that's what has to happen with even graphs. When you input a negative x, f of x stays the same. Let's look at this graph. If I take this relative max, and that would be the point x, f of x, and then I reflect it with respect to the origin, which is in the middle, that means it's going to be reflected over y and then reflected over x, and it ends up down here. So if we think about what that notation looks like, that point is going to actually be negative x, negative f of x. So when we're thinking about odd graphs, when you insert a negative x, it's going to change the y value, the output, to negative as well. And let's take a look at this graph. So if I have this point, which does look to be 1, 1, that is my point x, f of x. And if I reflect it over y, I get a point here. If I then reflect it over x, I get a point here. And that's not on my graph. So this would be an example of neither. So let's recap, and this would be a good slide to get in your notes. Each time we're testing this, we are plugging in f of negative x. We want to see what's going to happen when we do that f of negative x. So when we do it in the first graph, f of x stays the same. That means it's even. When we do it in the second graph, when we plug in negative x, it comes out, look at the negative is in front, which means it's the opposite of what I started with. So both of those are now negative. And when they don't match up, when they don't do either, then we're going to call that neither. So let's try this algebraically with some equations. So we want to start by plugging in negative x and seeing what happens. So if I plug in f of negative x, and then into each x I plug it in as a negative with parentheses, and then I simplify, well, negative x to the fifth is still going to be negative, plus a negative is going to make that negative, and I end up that I have now changed both of my signs. They were both positive, now they're both negative, so because both sides changed, that means that's going to be odd. Let's look at our second example. If I do f of negative x, and I plug in the negative x, now it's raised to the fourth degree, I'm going to have 1 minus negative x to the fourth is actually going to be positive 4. And it stayed exactly the same. My sign stayed the same, positive, negative, so this would be an even. And let's try it on the last one. F of negative x, plug in the negative x to both places. So I get negative 2x minus x squared. Well, this started out as a plus negative, but now it's a negative negative. Doesn't follow the same pattern. So this one would be an example of neither. And here's a recap. So if f of negative x equals the opposite of f of x, all the signs change, then it's odd. If f of negative x equals the exact same thing, then it's going to be even. And if f of negative x is not equal to either of those, then it's going to be neither.